Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Mastering Data Structures and Algorithms in Java series. Today this is the second part of data structure matrix. So in the earlier episode we covered the theory part. In this one we'll take a look at the code examples. So let's start. Okay. So let's start with a 2D matrix code example. We have a question given an n cross n 2D matrix, rotate by 90 degrees clockwise. Okay, so we are given the input, that is 1 2 3 4 5 6 7 8 9, and we have to deliver the output 741 852 963. Okay, let's see. So this is, what is this? This is matrix, right? So we'll say matrix part 2. So we are given the array 1 2 3 4 5 6 7 8 9, and we have to change it to, we have to rotate it 90 degree on the clockwise direction. So it will become 1 2 3 will come here, 1 2 3. Then similarly 7 4 1 will come on top, 7 4 1, because 7 will go here, 1 moves here, similarly 4 moves here, 2 moves here, right? So we get 7 4 1. Similarly we'll get 8 5 2 and 9 6 3. Okay, but how do we solve it, right? Okay, you can think of any algorithm that you would choose to solve this. How would you rotate this matrix? There are multiple possibilities, but we can take the one that is, will calculate the transpose of the matrix. So in step 1 we'll transpose the matrix. Okay, and then once we have transposed the matrix, then we can reverse each row. So transpose of a matrix is nothing but changing the rows to column. So we have 1 2 3 4 5 6 7 8 9. We have two steps: transpose the matrix and then reverse each row. So transpose is actually converting the rows to columns. So these, all the rows will switch to columns. So let's see, 1 2 3 will become 1 2 3, and then 4 5 6, and then 7 8 9. Okay, this will be our new 2D matrix after step 1. After step 2 we'll again reverse each row. So 1 4 7 will get reversed to 7 4 1. 2 5 8 will become 8 5 2. 3 6 9 will become 9 6 3. And this is our solution if you match, right? So it's a very simple problem and simple solution. So let's go and let's code this problem. Okay, if there are any questions during the video or anywhere, please let me know in the comment section. Okay, let's create another class, Java class. We'll name it, one second, matrix 2D. Okay, now public static void main. There are two I in public static void main string args. Okay, so first we need our input matrix. So it's a 2D matrix, is equal to, we'll provide the values directly. Okay, so we can say 1 2 3, then next line 4 5 6, and 7 8, 9. Okay, right. Now what do we want to do? We want to rotate this. So we'll create a method, and we'll call that method, we'll pass this matrix. Okay, now once we have rotated the matrix, we can print it. So we'll print the matrix. We'll use the for each loop from matrix. We'll fetch the row, and from each row for int num from row we'll fetch the value. Okay, so we can say system.out dot not println but print num plus, we need some space. Okay, and one more. Okay, one new line. Right, now all we have done as of now is we have just initialized the matrix, and we are going to call the rotate method. Now if we look at here, we have the matrix 1 2 3 4 5 6 7 8 9. We have to perform two operations to finally reach to 7 4 1 8 5 2 and 9 6 3. So first we have to transpose the matrix, and then we have to reverse each row. Okay, so let's start. Let's create, where is the main method ending here? Okay, so we'll create public static void rotate. Input is matrix. Okay, first let's find the length is equal to matrix dot length. We have the length. Now we'll transpose the matrix. Okay, so for int I is equal to 0, I is less than n, I plus plus. For so this is just the traversal that we are doing, as we have already covered this in the first part of the matrix data structure. In j is equal to 1, we have to start it from 1, j is less than n, j plus plus. Okay, now we want to do a transpose of the matrix. So if we look at it here, 1 is still 1, but 2 becomes 4, right? So that's why the for loop I series is starting from 1, but the j series is starting from 1. Sorry, I series will start from 0, j series will start from 1. Now what we will do is array of or matrix of ij. So ij would be this, in this case it will be 0 1, will become matrix of ji, that will be 1 0. So 2 will replace 4, and similarly 3 will replace 7, 5 will remain as it is, 6 will replace 8, and 9 will remain as it is. If you see, 2 replaces 4, 2 comes here, 4 comes there, right? So let's so we need a temporary variable is equal to matrix I j. Okay, then matrix of I j is equal to matrix of j I. Okay, and then matrix j I is equal to temp. Okay, so for int I is equal to 0, I less than n, I plus plus. For int j is equal to 1, j is equal to 1, that will make j equal to 1 every time. No, this is j equal to I. Okay, so for int I equal to 0, I less than n, I plus plus, j is equal to I, j less than n, j plus plus. Okay, now after this we have transposed the matrix. Next we'll reverse it, reverse for the each row. So reverse reverse each row. Okay, so we'll say for int I is equal to 0, I less than n, I plus plus. Now this time we have to traverse the complete matrix. So what we were doing last time is I is starting from 0 and the j is starting from I, right? Because for each row we want to reverse it to the column. But now once this array is formed, we have to traverse each row level by level. So we'll go I equal to 0 to n minus 1 and j equal to 0 to n minus 1. Okay, so for int j is equal to 0, j is less than n, or actually we can take n by 2 because we only have to reverse it, right? So it's like this: if 4 is reversed with 6 and 5 is reversed with 5, we don't have to go forward and reverse 6 again with 4. So we only go till the half. So j is equal to 0, j is less than n by 2, j plus plus. Okay, now we can say same, int temp is equal to matrix of I, j. So we get the first value, that would in this case be 1. Next we say matrix of I, j is equal to matrix of, now what value should we fill here? Because for us to reverse this, in one's place we want 7, so we can get it by total length minus 1 minus I, because it could have happened that let's say we have a longer row, 1 2 3 4 5 6 7. We replace 1 with 7 and 2 with 6, 3 with 5. So we have to write the formula as matrix of I, j will be equal to matrix of, I will remain same since this is for denoting which row we are at. So like this row or this row. But if the row is very long, or just to understand this example, the j column will have n minus 1, that is the last point. N minus 1 will fetch us the last one, but 1 will be swapped with 7, 2 will be swapped with 6. So since this is increasing, this should decrease, so we have to remove one more variable from here, so minus j. Okay, oh, it came down. Okay, if we go here, yeah, n minus j. Okay, so let's go back and code this. So I will remain same, and instead of j it will be n minus 1 minus j. Okay, now matrix of I, n minus 1 minus j will be equal to temp. That's it, right? So we have transposed the matrix and then we reversed each row. So let's run it. Oh, we are getting an error somewhere. Why? Somewhere we are getting an error. Okay, might not have been initialized. Why? Wait, it's saying line number 12. Oh, there's no problem in line number 12. Oh, okay, sorry. Okay, there was a typo. Okay, so 741852963, as we had expected, 741852963. Okay, so this was on the 2D array. Similarly, I will solve one problem for the 3D array as well. Since we already covered in very details, we have picked up a smaller problem for the 3D array just to understand how do we do it with the code structure. Okay, so we are given a 3D array, 3D matrix. We have to find the maximum element in the matrix. As you can see from the input, we have 1 2 3 4 5 6 7 8 9, and now we have to find the maximum, and we are already aware the maximum is 12. Why this has been written like this? If you see 1 2 3 and just consider this part, this is an array or 1D array, right? If you match a set of arrays like this one and this one, it becomes a matrix. So now this matrix is enclosed in these brackets. Now if you imagine one more matrix like this, so this one matrix and one more set of 2D matrix, it becomes a 3D matrix, right? Okay, so let's solve this. And okay, I don't think we would have to do it here, so let's directly code for it. New Java class will call matrix 3D. Okay, public static void main string args. Okay, oh, we missed something. Okay, let's initialize our 3D matrix. Since it's 3D, 3 arrays matrix, we'll do it in the same manner. One columns and then another one, and then in the third one we'll initialize 1 2 3. This one gets over, we go next 4 5 6. This one is over, we go next, and then 7 8 9. Comma 10 11 12. Okay, so we have the matrix initialized. We'll simply say int max is equal to find max and pass the matrix. Okay, now we'll print system.out.println the maximum element in the 3D matrix. We should type 3D matrix is plus max. Okay, now we need a matrix to calculate the maximum from these values. I will simply traverse the array and then return the matrix, not the array but the complete 3D matrix. Okay, so we'll just traverse and return the max. So we'll say public static not void int find max, we get int matrix. Okay, so let's initialize the max. Int max is equal to integer dot min value. You know why do we initialize it with the min value? Because min value would be minus 2 raised to power 31, and it can happen that in your matrix there are values in the negative numbers as well. So let's say it could have been -4 as well. So rather than initializing it with the 0, we initialize it with the most negative value possible for an integer. So for integer range it is -2 raised to power 31, or as you can see here 214, it's a big number. Okay, though in this case if you initialize it with 0, that will work as well. Now let's traverse the matrix. Okay, since there are too many loops, we'll use for each for in. So we'll get layer from our matrix. So from this 3D matrix we are extracting a 2D matrix in the for each loop. Okay, now from this for each loop we'll extract a 1D matrix, that is an array. We can call it row from layer. Okay, now for the last one, so first we fetched this is the complete matrix here. First we fetched this 2D matrix. From this 2D matrix in our second for each loop we fetch this one row. Now from each row we'll fetch each element. Okay, we'll say for int element from row. Now we'll check if element is greater than max is equal to element. Okay, So it will traverse through the max, and in the end it will find, first the max will become 1, then it will become 2, 3, 4, 5, 6, 7, 8, 9, and in the end 12 would be the biggest, right? Once that's done, we can say return max. Okay, let's run this. So the answer is 12, and just for a double check, we'll insert a bigger number in the middle, so 20, and run it again. So the max is 20. So we just traverse through the 3D array and then return the maximum element. So in the previous video on theory and fundamentals, we have very well explained for the 2D matrix, the 1D matrices, the 2D matrix and the 3D matrices, 3D matrix. So I would encourage that first please go through the theory video and the fundamental videos. This video is just covering the basic problems on 2D and the 3D matrix. So first go through the theory and fundamental videos on the matrix. That will cover everything that you need to know from scratch. Okay, so that's all for today's video, everyone. If you like the video, please let me know in the comments, or if there are any questions or if something can be improved, please let me know in the comments. In the end, please like, share and subscribe. Thank you.